So the idea behind a bifurcation is we have a dynamical system, we have some control parameter that we're gradually changing such that fixed points collide with each other, or fixed points are born or fixed points are disappear, and we want to ask what is the behavior of the system when new fixed points appear or disappear, and this is what happens at a bifurcation. So to understand what's happening in 2 dimensions, let's first go back and recall what we've learned about 1-dimensional bifurcations. For example, let's think about the simplest case of a saddle node bifurcation. So we have, for example, we're plotting x dot as a function of x. We have some x dot with some function of x that also has a control parameter r. And as r varies, we go from having no fixed points to 2 fixed points at a saddle node bifurcation. So for example, we could have this behavior for x dot as a function of x, in which case the flow just goes to the right everywhere. And then as we change r, maybe this parabola crosses the x-axis, and so we have something that looks like this, with a stable fixed point and an unstable fixed point. So as we changed a single parameter, then we had the collision of the curve f of x with the x-axis, and we had the creation of fixed points. Now in 2D, the same type of bifurcation occurs. It just looks a smidgen more complicated, but it's really the same phenomenology. It's more natural to plot things as a function of x and y. So let's imagine that we have 2 null lines where x dot equals 0, y dot equals 0. For example, here is the null line, for example, f, x, y, with a control parameter r equals 0. And here's another curve, a null line g, x, y, r equals 0. As we change r, these 2 null lines can move in this state space, and let's suppose that they collide with each other. After the collision has occurred, we might have a picture that looks like this. And now we have 2 fixed points. And if you just turn this 45 degrees, it doesn't look so different from the 1-dimensional bifurcation. So in 1-dimensional bifurcation, we have a collision of the curve f of x with the x-axis. In 2 dimensions, we have the collision of 2 null lines with each other and giving rise to either the birth or disappearance of fixed points. So the phenomenology of many 2-dimensional bifurcations is very similar to that as in 1 dimension.